So in chapter 5, we learned how to prove that triangles are congruent. Now in section 7.3 and 7.4, we're going to learn how to prove that triangles are similar. We're not writing proofs, but we're going to use similarity postulates just like we used congruency postulates in chapter 5. So the first one in section 7.3 is the angle-angle similarity postulate, which says that if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. What does it mean for triangles to be similar again? It means that all corresponding angles are congruent and all corresponding side lengths are proportional. But if we have two angles of one triangle congruent to two angles of another triangle, that's enough to conclude that my triangles are similar. So determine if the triangles are similar. If they are similar, write a similarity statement. So right now, we already know that angle G is congruent to angle L because they're both 90-degree angles. And then, as of right now, H is not congruent to J, but we don't know what the measure of angle F and H, the measure of angle F and K are. So let's find them. We know that the three angles in a triangle add up to 180 degrees. So if we add these three angles together, they're going to total 180 degrees. So we really have 151 plus the measure of angle F equals 180. Subtract 151 from 180, and we now know that the measure of angle F is 29 degrees. So the measure of angle F is actually congruent to the measure of angle J. So we know that angle F is congruent to angle J. And now we have enough information to conclude that these two triangles are similar because we have two angles of one triangle congruent to two angles of another triangle. So I'm going to name this first one HGF. It's similar to, and we have to match up corresponding parts. So we did 61, 90, 29. So we have to do the same thing over here. 61, 90, 29. So triangle KLJ. Here we already have one angle. We know that this 48-degree angle is congruent to this 48-degree angle. Now, where are my two triangles? Let me outline them. There's triangle RST, so that's a smaller triangle, and then there's triangle RUV. So we know that angle U in the big triangle is congruent to angle, now I can't call this angle S because there's actually two angles at S, so we have to use three letters to name this angle, so we'll name it angle RST. So there's one angle. Where's the second angle? It's actually angle R because angle R belongs to the small triangle and the big triangle. So we know that angle, and instead of, oh, we can just say angle R is congruent to angle R. We could use three letters, but yep, angle R in the small triangle is congruent to angle R in the big triangle. So now we have enough information to conclude by the angle-angle similarity postulate that triangle, the small one is RST, is similar to triangle, and the big one is RUV. So I made sure that I matched up my corresponding parts for my similarity statement. There we sort of had the reflexive property, right? Angle R is congruent to angle R. It's congruent to itself because it's the same angle. Here we have vertical angles. So we know that this angle is congruent to this angle because they are vertical angles. So we can name this angle LMK is congruent to angle PMN. And notice I still matched up corresponding parts there. I started with the 85-degree angle, I came in, and then same thing. I started with the 85-degree angle over here and came in. So that's one angle. My second angle is the 85-degree angle. We know that angle L is congruent to angle P because they're both 85 degrees. And now we have two angles of one triangle congruent to two angles of another triangle, so we can conclude that my two triangles are similar. So since I already matched up corresponding parts for the angles, I can just use those for the names of my triangles. So triangle LMK is similar to triangle PMN. Which means that I now know that angle K is congruent to angle N because my triangles are similar, so all the corresponding angles are congruent. We only needed 2 to prove that they were similar, but now we can gather that all 3 corresponding angles are congruent. So a hockey player passes a puck to a teammate by bouncing the puck off the wall of the rink. So here's the hockey player. He bounces the puck off to his teammate. According to the laws of physics, the angles that the path of the puck makes with the wall are congruent. So they are telling us that these 2 angles are congruent. How far from the wall will the teammate, here's the teammate, pick up the pass? So we want to know this value right here, x. So first, we have to, in order to set up a proportion to solve for x, we have to first know that the corresponding side lengths are proportional. And the way that we would know that is if we prove the triangles are similar. So in order to prove that the triangles are similar, we need 2 angles of one triangle congruent to 2 angles of another triangle. So we know angle B is congruent to angle E because they're both 90-degree angles. And then they told me that angle ACB is congruent to angle DCE. And so now by the angle-angle similarity postulate, we can conclude that triangle ACB is similar to triangle DCE. And because they're similar, by definition, we know that corresponding side lengths are proportional. So now we can set up a proportion to solve for x. So I always start with the variable x in the small triangle corresponds to 25 in the big triangle. So I'm going to go small over big. Only because I like to start with my variable. You don't have to, but x came from the small triangle, which is why I'm doing small over big. And then we also have 28 in the small triangle corresponds to 40 in the big triangle. So make sure you keep it consistent. I did small over big equals small over big. So now we can cross multiply to solve for x. 40 times x gives me 40x. And 25 times 28 gives me 700. Divide both sides by 40, and we get that x equals 17.5. Do we have any units here? Yep, feet. 17.5 feet. Write a similarity statement for the triangles, so they're already telling us they're similar. You can see the 2 angles of the one triangle are congruent to the 2 angles of the other triangle. So I'm going to name the first one triangle ABC. Just keep it in alphabetical order. Is similar to triangle. So we want 1, 2, none. So let's go 1, 2, none. So triangle DEF. That is also in alphabetical order. Then solve for the variable. Now because my triangles are similar, we can set up a proportion for the side lengths because corresponding side lengths are proportional by definition. So y in the small triangle, I always start with my variable. You don't have to. There's multiple different proportions you can set up. Y in my small triangle corresponds to 15 in my big triangle. So if I do small over big, I have to make it equal small over big. So 3 in my small triangle corresponds to 5 in my big triangle. And now we can cross multiply to solve. 5 times y is 5y. 15 times 3 is 45. 45 divided by 5 is 9. So again, when you set up your proportion, just make sure you keep it consistent. Small over big equals small over big. Write a similarity statement for the triangles. I'm just going to point out where the second pair of angles are. Right, these are vertical angles. So we do know they're similar because we have 2 angles of one triangle congruent to 2 angles of another triangle. So let's name this first one. It doesn't matter. Let's go ABD. Is similar to triangle. So we did no marks, 2 marks, 1 mark. So we have to do the same thing over here. No marks, 2 marks, 1 mark. So that's triangle EBC. So just make sure I match up my corresponding parts. And now, because my triangles are similar, we can set up a proportion to solve for our unknown side length. So z, I always start with the variable, z in the small triangle corresponds to 6 in the big triangle. Okay, if you're always unsure, you can just match up the angle marks. So no marks to 1 mark, no marks to 1 mark. So z in the small corresponds to 6 in the big. And now let's go find another pair of side lengths. 6 in the small, okay, 6 goes from no marks to 2 marks. So no mark to 2 mark in the big triangle is 12. So 6 in the small corresponds to 12 in the big. Now we can cross multiply to solve for z. So 12z equals 6 times 6, which is 36. Divide by 12, and 36 divided by 12 is 3. So use a diagram to complete each statement. Triangle PQR, so that's no mark, 1 mark, 2 mark, is congruent to triangle LMN. So that's practicing matching up corresponding parts. Same thing here. So LM corresponds to PQ, and so LM corresponds to PQ, and what side in the small triangle corresponds to 20 in the big? That would be side MN. So they actually filled in those numbers. LM is 12, PQ is Y, equals MN, which is 15, over QR, which is 20. And now they want us to solve for Y, so let's cross multiply. 20 times 12 is 240, equals 15 times Y, which is 15Y. Divide both sides by 15, and we get Y equals 16. Use the diagram to complete each statement. The scale factor of triangle LMN to triangle PQR is what? So this is an indicator of which one we need to put on top, right? This has to go on top. This measurement has to go on bottom. So let's see. You can pick any two sides that you know. We did find what Y is. I suggest not using Y though, just in case we made a mistake. Use two side lengths that they give you just to be sure. So they told me that QR is 20 and MN is 15, but we want triangle LMN to go in the top because they wrote that first. So 15 corresponds to 20 in triangle PQR, and we can divide a 5 out of top and bottom to get our most simplified ratio of 3/4. So 3 to 4 is my scale factor. Here you can see these triangles are just, one of them is in a different orientation. So let's write a similarity statement. We just have to match up the angles. So triangle, let's say PQR is similar to triangle. So we went 90, no marks, 1 mark. So we have to go 90, no marks, 1 mark. So triangle FGE. Then solve for the variable. Because my triangles are similar, we know that corresponding side lengths are proportional. So we can set up a proportion. A in the big triangle corresponds to, well, let's see, we went 1 mark to 90. So 1 mark to 90 in the small is 16. And now we have to do big over small again. So 15 in the big triangle, which goes from 90 to no marks, corresponds to 10 in the small, because that is 90 to no mark. So we can cross multiply to solve for A. 10 times A is 10A. 15 times 16 is 240. 240 divided by 10 is 24 for A. And one more problem. we're going to look at some parallel lines. So we actually have two triangles here, and I'm going to separate them to begin with. You don't have to. It just makes it easier. So we have triangle AEB. And then we have this bigger triangle, ADC. There we go. Okay, so I'm going to label these. Oh, I'm going to just make this a little smaller. So this was AEB. And our big one was ADC. Okay, so I'm going to label the side lengths as well. In the small triangle, this side length was 10 and EB was 14. In the big triangle, the bottom side DC is X, and this is the hardest part of this problem, is that how long is AD? AD is 10 plus 15. So AD is 25. That's the important part of this problem. So let's write a similarity statement. Okay, we first have to know that they're similar. So angle A is overlapping, so we know that angle A is congruent to angle A. And then when you look at parallel lines, in this example, we have corresponding angles that are congruent. So I'm going to just extend these lines, the parallel lines, so you can see. And this is my transversal here. And so this angle is in the top right position, and this angle is in the top right position. So those angles are congruent. And we also have another set of corresponding angles here. They're both in the top left position, so they're congruent to each other. So we do know that these two triangles are similar, so which is why we can write a similarity statement. So let's do that first. We know that triangle AEB, so that's my small triangle, is similar to triangle ADC. So now we can set up a proportion to solve for x. So x in the big corresponds to 14 in the small. So I'm doing big over small. Equals 25 in the big corresponds to 10 in the small. And then we can cross multiply to solve for x. So we get 10x equals 25 times 14, which is 350, divided by 10. 350 divided by 10 is 35.